Today's notes are on polynomial inequalities. We're going to talk about two different methods to solve polynomial inequalities. The first one is what we call the method of sign analysis. So what I want you to do is just copy down the steps to go through solving polynomials using the sign analysis. The first step would be to get everything to one side of the inequality symbol. Just to make sure that you've got 0 on the other side. Because the next step is to find the zeros of the polynomial by setting it equal to 0 and factoring. I will talk about some of the factoring methods that you should remember from Algebra 2. What we're going to do is plot the zeros then on a number line. What this is going to do is break the number line up into intervals. Then we're going to choose an x value in each interval. And plug it into the inequality. What we're looking for when we take the x value and plug it into the inequality, we're looking for if it makes the inequality true or if it makes the inequality false. If you get a true inequality, a true statement, then that entire interval is part of your solution. If you take your x value and you plug it into the inequality and you get a false statement, if it makes the inequality not come out true, then that means the interval is not part of your solution. So let's take a look at an example. We'll call this example 1. The polynomial is x to the third minus 2x squared is less than 3x. Looking back up at the steps, I can see the first thing we should do is get everything onto one side. And then this is going to be the inequality that I use for later on in the problem. So what we're going to do is find the zeros by factoring. So to find the zeros, I'm going to factor out an x, which leaves me with x squared minus 2x minus 3. And then I'm going to factor that quadratic into x minus 3. X plus 1 is equal to 0. And use that zero product property. That means you take each piece and set it equal to 0 and solve. Or most of you might just want to skip and say x is equal to 0, 3, and negative 1. So these are the numbers that I'm going to mark on my number line. I'm going to put them in numerical order. So negative 1, and then a 0, and then a 3. And you can see that now I've broken my number line into 4 different intervals. So that means I'm going to choose 4 different numbers to test in my inequality and see if it comes out with true or false statements. So the first thing I'm going to do is test a negative 2. So I'm going to put negative 2 into the starred inequality. So negative 2 to the third minus 2 times negative 2 squared minus 3 times negative 2. And I'm asking myself, is that less than 0? It comes out to be negative 10. And so since that made a true statement, that means this whole interval is part of my answer. We're going to go on and test x equals negative 1/2. So again, just go ahead and put negative 1/2. And again, we're looking to see, is that less than 0? This one comes out to a 0.8 0.75. Since that's not less than 0, that means there's no number between -1 and 0 that's going to be part of my answer. I'm just going to move on and test x equals 1, because I could have chosen any number between 0 and 3. You don't want to choose the actual endpoints of the interval, just any number you want between 0 and 3. 1 seemed easy to me. And again, is that less than 0? It comes out to be -4. So since that is a true statement, that means this entire interval is part of my solution. And the last one I tested was x equals 4. So whenever I plugged 4 in, it came out to be 20 is greater than 0. That's not true, and so that is not part of my answer. So once you decide which intervals are going to be part of your answer, we're going to write it out in interval notation. So interval notation is the one with the parentheses and brackets. So this one's from -infinity up until -1. I'm going to use a parenthesis there because at -1, I'd be equal to 0, and I don't want my inequality equal to 0. Then I also want between 0 and 3, and again, I'm not including those endpoints for the same reason, and then you just combine the 2 with a u. Now we're going to look at a second method that you could use to solve polynomial inequalities. And this method would be called graphing method or sketching. Yeah, I think I like sketching better. Because it's not like a formal graph. We're kind of just doing our best to do just a rough sketch. But the first two steps are the same as with the sign analysis. The only thing that's different is in number 3, instead of plotting them on a number line, we're going to plot the zeros on the coordinate plane. From there, we're going to use the leading term test. Some of you might have learned that as end behavior, and we're going to use that to sketch. So remember that leading term test involved looking at the degree of the polynomial and the leading coefficient. Then the fifth step is if we're looking for where that polynomial is less than 0, we're going to look where the graph is below the x-axis. If we're trying to solve where the polynomial is greater than 0, we're going to try to find where the graph is above the x-axis. So thinking back to that last example, we had already found that the zeros were 0, -1, and 3. So I'm going to pick up on that problem just where things become different with the two methods. So in this one, I'm going to plot them here on the coordinate plane. There's a 0, -1, and 3. So that's what I mean by plotting them on the coordinate plane. And the polynomial was an x to the third. And so that means I had a positive leading coefficient and an odd degree. So that means my end behavior should be down and then up. So I would take that idea and know that I have to go through all of those zeros and kind of fit it back in like a puzzle to see what that graph might look like. So I think it's probably going to look something like that. Now it's okay. It's not going to be a perfect sketch. I don't know if that was high enough or if that was low enough. It doesn't really matter. All we're looking for is where is it above or below the x-axis. Now in this example, we're trying to solve x to the third minus 2x squared minus 3x is less than 0. So since we wanted less than 0, we wanted the places where it was below the x-axis. So that would mean this right here and this right here. So the interval notation is always along the x-axis. So we would still get the same answer of -infinity to -1. And then from 0 to 3.